Hello there. In a couple of videos ago, we described how to do confidence intervals and hypothesis testing on the population proportion. In this video, we're going to consider two different populations, A and B, with different proportions, pi A and pi B. And we're going to learn how to perform a hypothesis test on the difference between these population proportions. So, as you may recall, the confidence interval is surrounded by a z-test, with a standard error of the estimate for the proportion to be p hat 1 minus p hat over the sample size. The confidence interval for the population proportion difference has the pretty much same structure. We're still going to be using a z-critical value, and we're going to sum up the standard error of the estimates for the different proportions of the estimates for each of the populations. So, as a guiding example, let us consider this possible case. Suppose you are studying people's opinions on a proposed bill across various cities. Let us assume that City A has a 76% approval rating for some bill, and let us assume 67% of City B had an approval rating. And let us assume we surveyed 75 and 87 people. Let us assume that it was independent and random as usual. So one of the questions one may ask is there a significant difference in the approval ratings among these two cities? Alright, so let us begin with the same exact setup. So we're going to be working with the null hypothesis that the difference, or pi A minus pi B, is equal to 0. So if we are in favor of this null alternative, that means there is no significant difference between 76 and 67. So we're going to work with the normal two-sided alternative. Pi d does not equal to 0. This implies that there is a significant difference between these two. Let us also assume that we're going to be working under let's work with a 98% level of confidence here. That implies that our statistical level of significance is going to be 0.02. So one may find that the z-critical value, z alpha over 2, if you're in Excel, you can do this by norm.s.imv. And since we're working with a two-sided confidence region, that means this area, C, can be found, or this critical value can be found by the formula 1 plus C over 2. So in this case, this is going to be norm.s.imv of 1.98 divided by 2. So once you do that in Excel, you're going to get some number that's going to be approximately equal to 2.326. So this is the critical value for our confidence interval. So once we have that, then we can calculate our marginal error. So our margin of error is going to be our z-critical value, 2.326, multiplied by the square root of the sum of our different standard error of the estimates. So our first sample had a proportion of 0.76, that's the approval. So our disapproval is going to be 1 minus 0.76 divided by its sample size, which we surveyed 75 people. And then the other sample was 0.67 times our disapproval rating, 1 minus 0.67, divided by its sample size, plus 87. So if you do this correctly, the square root term should come out to approximately 0.071. So that's going to give us a marginal error of about 0.164, which is the same thing as 16.4%. Alright, so remember, p hat A was equal to 0.76 and p hat B was equal to 0.67. So if we define p hat D to be equal to p hat A minus p hat B, that's going to be equal to 0.76 minus 0.67, which is going to be equal to 0.09. So this is going to be our point estimate for pi D. Alright, so with that being said, we can now construct our confidence interval for the difference of proportions and our level of confidence. So again, that's going to be p hat d minus our margin of error and p hat d plus our margin of error. So our estimate is going to be 0.09 minus our margin of error, which came out to 0.16, and then 0.09 plus 0.16. So that means the confidence interval for our population proportion difference under a 98% level of confidence is going to be equal to negative 0.07 and 0.25. So this is what we're going to sort of work with in terms of making our conclusions. So remember, our null alternative was, or our null hypothesis was, that pi d was equal to 0. So if we sort of look at these numbers, so this is negative 0.07, 0.25, our null hypothesis, pi d 0, which is 0, lies in between our confidence interval, right? So that means our samples pretty much agree with one another. That is, the proportions are about the same. That is, the difference is about equal to 0. So if that is true, then that means we're going to fail to reject the null hypothesis. And that's since 0 lies within our confidence interval for the population difference. So with that being said, what does that mean? So that means we have evidence to believe, under a 98% level of confidence, that the approval ratings among city A and B are about, keyword here is about, the same. Now, pi a and pi d might not be equal to one another, but the difference between them might significantly be really small. And this is pretty much how you conduct a hypothesis test on the population proportion difference. Now, some things that you may want to keep in mind here. Remember that for the confidence interval for pi, we mandated that n times p hat usually bigger than or equal to 10, and n times 1 minus p hat was also bigger than or equal to 10. That is, the expected number of approvals and expected number of disapprovals was larger than or equal to 10. This is sort of like you know, if the sample size is significantly large kind of check. So the same type of conditions can be measured for the pi difference, namely n1 times p hat 1 must be bigger than or equal to 10, n1 times 1 minus p hat 1 must be bigger than or equal to 10, and the same for the second sample, n2 times p hat 2 must be bigger than or equal to 10, and n2 times p1 minus p hat 2 must be bigger than or equal to 10. Of course, these are subjective. Some people increase these numbers to 20, some people decrease them down to 5, since you have 2 samples, but it really depends on the survey. So it's really useful to take into consideration what you're measuring, how serious you are in making terms of errors, and the distribution of the populations as well. It's always useful if the populations are normal, the samples are random and simple and independent, because once you break these assumptions, then usually the interpretations are sometimes misleading. But that's pretty much the breakdown of how to do hypothesis testing for the proportion population difference.